All right, so now we're going to look at measures of variation. It says cumulative frequency. So box and whisker plots, standard deviation. So these in blue, we're not going to look at, but we're going to look at cumulative frequency. All right, so make sure you can see my screen, right, Shalom? I believe so. All right.
Yes, sir.
All right, so cumulative frequencies are useful if more detailed information is required about a set of data. What I would say about this thing, this cumulative frequency almost always come on the exam, right? So it's something that you guys must learn.
Okay.
So in particular, they can be used to find the median and interquartile range. The interquartile range contains the middle 50% of the sample, so it contains it and describes how spread out the data are. This is illustrated in work example number 2. So for the data given in the table, draw up a cumulative frequency table and then draw a cumulative frequency graph. So you have this table given, so you have the height, I guess could be the height of some students, height of, I don't know, people in a community. Frequency, all right, number of times they appear, numbers appear in this class. And then here's a solution. Now it's the table opposite shows how to calculate the cumulative frequencies. So if you look, you're basically just adding up these numbers one after the other. So you start off with 5 plus 22 is 27. 27 plus 30 is 57. You just keep adding, and that would give you the cumulative frequency. So you start off with 5, then 5 plus 22, 27, 27 plus 30, 57, 57 plus 31, 88, and it goes on. So you have this table now. Then it says that a graph can be plotted using points as shown opposite. So see it here, so you go 90, 0. This one is what? 105. So it says it gives, so 0 here. So 90, 0. 105, the 5 would come from here, the 100 would be this point here. And then they can guess that other one is 110, 110, 27. And then 100 and, so I guess I can look at these endpoints. So 105, or let me say it another way. So 90, 90 being on the x-axis. So 90 and then 5. No, I say it wrong. 90 then 0, then 105, then 110, 27. See it's here, 110, 27. Let me see if I can small this up so that it can show. Yes, great. Then 120, 57. So you just keep plotting. 130 on the x-axis, 88 on the y-axis, 140 on the x-axis, 106 on the y-axis, 150 on the x-axis, 112 on the y-axis. So look at this nice curve. Cumulative frequency, right? Curve. And here's another one. So a more accurate graph is shown. It's by drawing a smooth curve through the points rather than using straight line. Right. Let me see. Well, yeah, I guess so. This would be this to me is a smooth curve, and this to me is a straight line. So I don't know the point I'm making. I say more accurate graph is formed by drawing a smooth curve through the points rather than using straight line segments. And they have this. So I guess this would be the straight line segments, and the one above is a smooth curve. Example 2, the cumulative frequency graph below gives the results of 120 students on a test. Look at this, nice, like a nice S. So you can say that these are the test scores on the x-axis and the number of students that, you know, get a particular score cumulatively on the y-axis. So if you were to choose a point at random, you could say 20 students got around, got less, got up to 40 on their test score, right? So you know, so as I can see, some going to get less than 40. Well, all of them, it's up to 40. So 40 or less. So, you know, meaning, you know, you're going to have 20, 30, whatever test scores. And that is represented by 20 students got up to 40. Or you can say 40 or less on the test score. Let me choose another point. Let me choose this one. This look like 90, right? So 90 students. So you could say 90 students got 60 or less on the test score, right? So let us see what they ask. So use the graph to find the median score, the interquartile range, mark which was attained by the top 10% of students, the number of students who scored more than 75 on the test. All right. So it says since half of 120 is 60, the median can be found by starting at 60 on the vertical scale, moving horizontally to the graph line, and then moving vertically down to meet the horizontal scale. In this case, median is 53. So they show like a piece here, and we can go to the original here. So remember, say it's 120 students, right? So you have, in essence, 120 test scores. So you want to find the test score that is in the middle. So it's not by going here and then going up and then going here. You go this, you use the y-axis because they're going to find the student that got the score. Let me say it another way. You want to find the score that lands in the middle, right? So you know that there are 120 scores, and you want to find the score that lands in the middle. So you're going to say, all right, halfway is right here. You go across, touch this line, and you come down. So you can say the student in the middle, his score was, this look like about 50 something. Let's see. So it said 53. And then it says to find out the interquartile range, we must consider the middle 50% of the students. Hold on, let me. Not sure if you're hearing that WhatsApp notification coming in.
Yes, sir, I heard it.
You heard it.
Yes,
All right, let me see if I can get rid of it. All right. So it said to find out the interquartile range, we must consider the middle 50% of the students. So to find find the lower quartile, start at, all right, so maybe this is the way I should say it, because there is no place that they define the interquartile range. I think what they told us up top was so vague, it just said the interquartile range contains only 50% of the sample and describes how spread out the data. All right, that's what it says, right? But this is where they put the definition. which I would probably say, look at this first, how it's defined, and then you can understand how, what to do. So the interquartile range is the difference between the upper quartile and the lower quartile. So what are these things saying? So the lower quartile basically is given at a point which represents 25% of the data. And the upper quartile, so the lower quartile give you the lower 25% point, and the upper quartile give you the upper 25% point. So what are we saying? So lower quartile, so you have 120 data points, 120 students. So 25%, the lower 25%, because remember, they have this senior find. They don't give a table, but so let me just work with that. They don't give a table, but you have these students line up because the questions are 120 of them. Paper cannot be signed. Gives the results of 120 students, 120 of them. So these students are gonna have the low scores down here. And then the higher scores up top, as you can see by this. So the lower 25%, the 25% of 120 is 30, right? Or you can think of it as a quarter of 120 is 30. So around here will be your lower quarter. Right, so let's see. So your lower quarter, so find the lower quarter, start at that, which is 30. Right, so this point is 30, but what I do is to move, because asking for the score, let me see, make sure I ask the right question. So use the interquartile range. So it's referring to the score here. So check this out. So they go here, you find the 30, you take a quarters. Then you go to the line and you go down and you get 45. Then the upper quartile, look at the top 25% or the top quarter. So that will carry it to 90. You may say, sorry, that's not really clear. Just think of 25% at each. Right, so 25% represents 30. So if 30 is at the bottom, then if you count 30 from the top to down, you reach at 90. Right? So this 90, you're going to go across to the curve and come down. So that is the upper quartile. Come down. So if this was 100, say this was 100 students instead of 120, then instead of coming at 90 right there, you would be at 75, right? Because 25%, the top 25% would start from 75, and then the bottom 25% would start at 25. So that is if this was 100 instead of 120. But what we have here is 120, so we'll work with that. So 90 will come down, we'll get 67. Hopefully you can see what I'm doing with the mouse pointer. You get 67 once you come across to the curve, and that is the upper quartile score. So this is the score right here, and then the lower quartile score is here. So the interquartile range now is 64 minus 45. So it is that's kind of weird. So this something like is a mistake. This is supposed to be 64. So it's supposed to be 64 or 67. Let me see if I were to go up there. So let me make a mistake on that. So let us see. If we were to take 90 and go across and then come down, we get 60. That look like 60. Look like 60 to me. That is 6. Let me see. This look like the midpoint. Yeah, look like 60 to me.
So it looks like 60.
Yeah, look like 60. So I don't know. I guess they're gonna do it properly to scale. It looks like 60 to me, but I'll work with 64 for now. Then right here, so let me see. Just 30. If I were to come down, if I would get something close to 45. 30 that'll be about here. Let me see. Yeah, I would this look like something close to 45 because the middle right here is at 50. I'm gonna necessarily close to 45. So I don't know how them draw it, but we just try to get the point, the gist of it, right? So it's
Yes,
I would
sir.
say it looked like 60 to me, but we work with 64. So we say okay, 64 minus 45, we get 19. And that's how we get the interquartile range as it relates to the test scores. So we'll go again, go up top. Well, the asks use a graph to find the interquartile range. So you need to use the frequency, the y-axis that gives the frequency, the cumulative frequency, and you find, let me use this one, you find the top 25%. In this case, the point is 90. You find the bottom 25%, in this case is 30. You go across to the curve, and you come down and get the score. You go across to the curve, come down and get the score. And then you take the difference between the top 25%, which is this one, take the difference between the top 25 and then the bottom 25. So see there, upper minus lower. And you get the difference. The interquartile range is the difference between the upper quartile and the lower quartile. And that's how you get it. So always remember, you get the points to go across by using the y-axis. Once I figure out the points, the top 25, the bottom 25, you go across to the y-axis, the x-axis, and you pick up the figures. Take the difference to find the interquartile range. All right. So what the next question says, it's the mark which was attained by the top 10% of the students. So if I look at this, the top 10% of the students are gonna be at the top, right? Clear, you know. So 10% of 120 is 20, right? So what are the solutions as it, right? So you know, let's say I can use this one, this curve up here. The top 10% are up here. So if we were to count from, so we said, what is it? 10%? Top 10%, what I get 12. I think that's a solution. Then I get 12. So so now you would account from 12 come down. So 12 come down, that's all 108. So you come 108. So I think this is about 110. Let me go right there. So 108. And you come across about here, so can't line it up so good. So around here. So if I come down, so this look like 78 there. So let us see. All right, see that 108. They come down. So they estimate them 79, right? So you come down, so here the mark, which was I think like top 10%. So 10% of 120, you get 12. And so you count from the 120 come down, as I'm saying, you start at 108, and you come across to the line, you come down, you get 79. I don't know, is that they pick up 79 and then it's a 78. 78 me to get still, so.
Yes, sir. Yes,
No
sir.
record 78. Then they ask another question. The number of students who scored more than 75 on the test. So if we were to go up top, 75, so 70 would be about here, 75 is around here. You go up top, You go across here. So look around here. So this look like bow. So this are 110. So this are bow, I don't know, bow 106. So the students are square about 75. So the difference between 106 and 120. Right? So that's about 14. So you could say 14 students score above 75. So that's my estimate. So go down. All right. All right. So to find the number of students who scored more than 75, start at 75. Right. So you start at 75, you go up and cut cross. This gives a cumulative frequency of 105. So the number of students that score greater than 75 is 15. So I think I got 14, 15, so 15, right? So it just say do the thing properly. So even though they represent 103 here, which is wrong, they're not agreeing. I don't know what happened. They're not agreeing with what they're saying. But it's about 15, 14. And then here's another example. The table below shows the distribution of marks on a test for a group of 70 students. You have the marks, you have the frequency, cumulative frequency. So you just add up. So this is 2 and 5 are 7, 7 and 9, 16, 16 and 14 are 30, 30 and 16 are 46. And it goes on, 46 and 12, you know, some number, 58, right? 58 and 8, 64, or 66. Oh, whatever, I'm gonna lose count. So we'll go down. It's a copy and complete the table to show the cumulative frequency for the distribution using a scale of 1 centimeter to represent 5 marks on the horizontal axis and 1 centimeter to represent 5 students on the vertical axis. Draw the cumulative frequency curve for the squares. What assumption have you made in drawing your curve to the point 0, 0? The pass mark for the test is 47. Use your graph to determine the number of students who pass the test. What is the probability that a student supposed to be that a student chosen at random had a mark less than or equal to 30? So you fill out this, 58, yeah, 66, yeah, 66, 70. Your graph on the following page, it's the assumption that no student scored 0. All right, so let us see. All right. So you go straight up. So let us see it with the small. So mark 10. So 10, oh, I have 2. So 10, 2, 20. Mark 20, I have 7. 20, I have 7. And you continue at 16. 16, yeah, so 30 mark, you get 16 students. So 30 of 16 students, and it goes on and on. And you're supposed to get this nice curve. So notice is this mark that matches up, the mark at the right endpoint that matches up with the cumulative points. So these would represent the right endpoint would represent your x-axis point, the x-coordinate points. Then these will represent your y coordinate points. All right. So the next thing it asks is, so after you copy and do all of that, the pass mark for the test is 47. Use your graph to determine the number of students who pass the test. All right, so the pass mark is 47. How many students pass the test? So everybody who's above 47. Well, this is 47. You come across everybody who lies above this, because these are the number of students now, would be those who got above 47 on the tests, right? So if you look, let me see how many students, I have 70 students, it stop at 70. This look like about 42 or 40, yeah, call it 42. So the difference between 70 and 42. Sounds like about 28. So 28, they're about, see there, 28. Then it says, it also, what is the probability that a student chosen at random had a mark less than or equal to 30? So less than or equal to 30. So less than or equal to 30. So around 16, so that'd be 16 students, 16 over 70 would be a probability. So 16 over 70, because there are 16 students that score less than 30, and there are 70 students in total. So you put the outcome that you're looking for, 16 over the total possible outcome, 70. And then you get, then it just reduces to the lowest term, right? That's how you do that. Here's another example. The heights in meters of a random sample of 40 students from a regiment were measured. The heights are summarized in the following table. So again, you can fill this out, 2 plus 4, 6, and then 6 plus 13, 19, and you continue, 19 plus 14, 33, I believe. And you continue until you get 40. Then it's a copy and complete cumulative frequency column table. So you complete all of this, that's nothing. Construct a cumulative frequency curve for the data. Write that nice little curve. And then estimate from this cumulative frequency curve the median, the upper quartile, lower quartile, compare your values of this and this. So this is your upper quartile, subtract your median, and then this is your let me say this is a median minus your lower quartile, right? So note this, this is very important, that Q2 is your median, which is in the middle, and your upper quartile is Q3, your lower quartile is Q1. So you do this thing now. So you have 1.75. You say no, this thing here is called a break. So sometimes so check it out. The score, this thing start from 1 at, you could say, let me see, 0 would be, 1.75, right? And then you start pick up now, you use the endpoint, as I said before, you write endpoint as the X coordinate, and your cumulative frequency figures as a Y. So this is 1.8 for X and 1 for Y. So it go up a little bump up, 1.8, but the one before it to put at 0. So 0, 1.7. So this thing right here, so 0, 0 for your Y and 1.75 for your X. And why they put this is because they just want to get to the 1.75 quicker. So like a break, so between 0 and 1.75. Because remember, you have 1, you'd have so many numbers that come before 1.75. So rather than start at 1.75 over yonder, here, they just say, okay, let's put 0, break the graph, and start at 1.75, and then go up to 1.8, 1.85, 1.9. So if anytime you book up on and I would say when you're practicing, you'll see where you should do it. It's not all the time you should do it. It don't make, if you look at the questions before, it don't make sense all the time to do a break. So that's what I'll say on that. Let me see. So check this out. 0, 5, 10, 15. You know, in a sense, you break right here, so and then go to, especially like, oh, this is a 110, 1 to 10. You say if this was like 50, then 60. And then you have like say 61 to 70. Then you could break. You would break and say, okay, 0, break, go 50, then 60. But because 0, 5, 10, you don't need to break. So that's what I'll say about the break for now. Yeah, and you continue, you go through, you done that. Then what else it asks for? It asks for the median. As I said, median is in the middle, so you look and you say, all right, so many students, 40 students, then 20 is in the middle, you go across to the curve, you go down 1.95, that'd be a median score. Then the upper quartile is 40 students, a quarter at the top, right? So your count, a quarter would be 10, you count down to 30, you go across to the curve, come down, you get around, I don't know, this is like 1.9, I don't know, 8, 99, I'd have to check, all right? So it's 1.99. So you go, and of course you can always figure these things out because you just look between here and here. So if you look, this is 10 little squares, I believe. Let me say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 little squares that cover 0.5. Meaning if you were to take the difference between 1.85 and 1.8, you would get 0.5 and 10 squares represent you would just divide so 0.5 divided by 10, how much that? Right. Hmm?
So can you repeat what you just said? My internet just
Oh,
dropped.
right. So I was making a point that if you take the difference between 1.85 and 1.8, you get 0.05 and you divide it by 10 because you have 10 little squares. So think about it, 0.05. Maybe I should write it down. To just to show you. I just carry the decimal place over a little, and then you see what you're really working with. Let's see. Can you see my screen still?
Yes, sir. I'm seeing it.
All right. So just making the point that design ideas. It was something like so you have 10 little squares, or 10 little squares, and the difference is you have 1.85 and I think 1.8. So I was making the point that this is just 0.05. And if you want to know what one square represents, one square represents right? Which you carry over. Right? So that's what one square represents. So when you put two squares together now, two squares, you add these two, you get right? Two square. So if you look, at what we did before, where's my mouse? If you look at this thing when they put it here, so putting it here would go up to, let's see, you have 1, 2, 3, 4, 5, 6, 7, 8. We have 9, 10. So this is 8. So we're going to say, all right, 8. So 8 times 0.05. How much that? So this should be about, so we need to be off the top of my head now. Right? Because 8.5 is 40.
0.04.
Right? So you would get this. So in the question around here, this is 9. So this is 1.95 plus 0.04 because 0.04 would carry here, which is 1.99. Hopefully you see that.
Okay. Yes,
Yes,
sir.
you see it. All right.
Yes, sir.
So that's how they get it, right? So usually one square, would be like, all right, they would set it up in a way where one you can just look at one square and say, okay, this is like a 0.1 or a 0.2 or whatever. But in this case, one square is 0.0, I think it's 0.005. So let me make sure I check. Yeah, one square is 0.005. Yeah, so usually one square would represent like one. So either 0.01 or 0.001 or with someone, but in this case is 0.005. All right, so we'll move on. So see, when you do, the lower quartile, which is here, right? And then you do the upper quartile, which is here, and then the middle is here. And then for someone in the answer the difference between the upper quartile and the median. I think this is a median here, so you take the upper quartile, which is 1.99 minus 1.955, you get 0.035. And then this one is a median, 1.955 minus the lower quartile, which is this one out here. So that looks like 1.915. We take the difference to get 0.04. All right. Then what does this ask? Just to make sure it's a what does this indicate about the shape of the distribution? So after there's a compare the values at this, which is the differences of the upper quartile and the median and the lower quartile and the median. Then look at what it says. It says that this here, the difference between these two numbers, when you go here, and you tell the difference between this and this versus this and this and this is bigger than this and this. So the difference between the 1.95 and the 1.9 is bigger than well, not 1.90. These numbers that I was looking before. Let me use these. So this difference, 0.04, is bigger than 0.035. And all that they're saying is that hence positive skew to the data. That is, it is not symmetric. Now, I don't think that is required for you guys to know the CXA level, but it's good to just know in general. It just means that there are more people that have scores that are in the lower area that are closer to the bottom than to the top. Right? Is this scores is heights? All right, so deal with heights. So there are more people that are shorter than taller. That's one way you can look at it. More shorter people than taller people. All right. And then you have the exercises, right, that you can do on your own. So I put the answers for these in the group, right? So maybe I don't know if you have graph paper.
I still have a few left.
You have a few. All right. What I can do is let me see if I can find. Where did I hold a second? Desktop. Desktop-y. Literally I had it, yeah, see it here. So I think this is the first question. Let me see. Make a cumulative frequency table for each of the 3 sets of data given below. Then for each set of data, draw a cumulative frequency graph and use it to find the median an interquartile range. So you have this. I like this. Notice that it starts at 60. So you now you have to put a break in that, because it don't make no sense now you're gonna put 0, then you're gonna go way out now and start the data point at I guess in this case, say 60, but you would put like the 80 would match the 4. So and the 60 would match the 0. So let us look. See it here? So look what they did. They just, so if they don't put a break line, it's like a break, because from here to here is 20 units. This box from here to here is 20, but here to here do look like 20. As in, well, it look like 20, but it's not showing 20. This is 0 to 60. So it's like there's a break right here. So if they don't put it, there's a break. Because this right here, if they were to draw it to scale, this box should be 3 times this box. So this one over here should be 3 times this over here if they are drawn it to scale. So good. So they put it, and then, you know, the median, you go to the middle is how much data? 100, you go to the middle 50, you cut across, you come down, so about 111, yeah. Up the lower quartile, so this is 100, so look at 25. About here, you come down. This is about, I don't know, probably 195. You go up, cut across. This is probably 130. So 95 and 130. So the difference. So they have approximately 30, because of course I'm just estimating with my mouse and just looking, right? So on and so forth. So you have a lot of questions can try. And the good thing is that I put in the solution. So when you use it on your graph paper, you can get a appreciation for how close you are. And some of them may be slightly off, as you can see where they put some of them, the numbers slightly off. But with your thing, you can test it for yourself. So that's all we would do this topic. I don't think I'm going to push to any other topic right now. But that's it. What we should be doing now are some past papers. So come in, and of course, do the box and whisker plots and these things. Just, and maybe I should double check the syllabus to make sure what I don't say any box and whisker plots and them things. Yeah. So I would end it there, and then you do the exercises as homework. I would say do at least 5 questions. So it starts here. So you'd go from, so question 1. Well, question 1 has quite a few. So question 1, question 2, 3, 4, 5. Yeah, do at least 5. Because the thing is, this question will come in exam. A question like this will come, so you need to practice. All right. So I think that's it. We will pick up again hopefully in the week, and we can look up a past paper question and call it a day.
Okay, sir.
All right. So take care now.
You too, sir. Have a good day.
Yeah, man. You too.